All right, good afternoon. I'm going to make this video on the PIC18F4525, and it's because I have a few of these coming in the mail, so I'd like to know a little bit about them before I get them. So I'm just collecting information. Now the data sheet for this is 412 pages, so I don't think I'm going to read all that. But I just want something I can put together. See what I can do. I'll begin by reading just what shows up on the microchip website. I guess they still make this. Features up to 10 MIPS. Performance at 3 volts. I tried Google searching MIPS, and I got something else related to computer architecture. I thought this was something like the number of commands per second, like information per second or something like that. C compiler optimized RISC architecture. A reduced instruction set computer, or RISC, is a computer with a small, highly optimized set of instructions rather than the more specialized set often found in other types of architecture, such as in a complex instruction set computer. The main distinguishing feature of RISC architecture is that the instruction set is optimized with a large number of registers and a highly regular instruction pipeline. 8x8 single cycle hardware multiply. Internal oscillator support, 31 kHz to 8 MHz with 4x PLL. Fail-safe clock monitor allows safe shutdown if clock fails. Watchdog timer with separate RC oscillator. View more. I guess I read this stuff. Wide operating voltage range, 2 volts to 5.5 volts. Nanowatt power managed modes, run, idle, sleep modes. Idle mode currents down to 5.8 microamps typical. Sleep mode currents down to 0.1 microamps typical. Analog features, 10-bit ADC, 12 channels, 100K samples per second. Programmable low voltage detection module, programmable brownout reset module, twin analog comparators, multiplexing. Peripherals, master synchronous serial port supports SPI and I2C master and slave mode. EUSART module including LIN bus support, 4 timer modules, up to 5 pulse width modulation outputs, up to 2 capture and compare. Parametrics, program memory type. Program memory type is flash. Program memory size, 48 kilobytes. Compared to the Arduino Uno has only 32 kilobytes of flash memory and 2 kilobytes of SRAM. So this chip has more flash memory. I am wondering if program memory is the same as flash memory. CPU speed is 10 MIPS. SRAM is 3968. Arduino is 2 kilobytes, so the PIC has more. Data EEPROM is 1024 bytes. So I guess the SRAM is like the working memory, or the working RAM, just while the thing is running. EEPROM for the Arduino is 1 kilobyte. Looks like microchip is the same, about. Digital communication, UART, SPI, I2C, MSSPS. Capture, compare, I don't know what that is yet. Timers, ADC input, numbers and comparators 2, temperature range, operating voltage 2 to 5.5, 40 pins. This might be a little bit boring. But I'll go through the pinouts. It's probably something I want to see over and again. So 11 and 12 and 31 and 32 are VDD and VSS connections. Pin 1 is like, I guess it could be different setups, mClear being one of them. Some of these other acronym things I don't know what they are yet, like this is probably for I2C here. Here's some I2C stuff, SCK, SCL, or maybe that's SPI. Well, maybe I won't go over all these things. Not fun to read, but maybe somehow when I come across these things I can match them up to the pin diagram. Alright, so usually the first couple pages of the datasheet are good for a general description. Microchip, PIC10F, or PIC18F4525 up to the 4525 and the 4620. And that ranges all the different pins for all these different chips. Enhanced flash microcontrollers. So maybe this 48 kilobyte size is maybe a feature for this chip. It's got more flash memory, more program code memory, with a 10-bit analog to digital and nanowatt technology. I guess I'll be comparing everything to the Arduino, given I know that. I mean, I know the Arduino a little bit better. The Arduino does not have a digital to analog converter. It has a 10-bit analog to digital converter with multiple inputs, and it has a 8-bit PWM outputs which can substitute for analog output for some applications. But it won't work for good quality voice or music. Well, I guess the microchip 4525 has 10-bit analog to digital converter. This looks more like legal disclaimer kind of stuff. Power management features. Run CPU on peripherals on, idle CPU off, peripherals on, sleep CPU off, peripherals off, ultra-low 50 nanoamp input leakage, run mode currents down to 11 microamps typical, idle mode currents down to 2.5 microamps typical, sleep mode current down to 100 nanoamps typical, timer 1 oscillator 900 nanoamps 32 kilohertz 2 volts, watchdog timer 1.4 microamps 2 volts typical, 2-speed oscillator startup. I guess maybe if these are being used in finished products, then maybe the power management is important. It's not that important to me. Flexible oscillator structure, 4 crystal modes up to 40 megahertz, 4 times phase lock loop available for crystal and internal oscillators, 2 external RC modes up to 4 megahertz, 2 external clock modes up to 40 megahertz, internal oscillator block, fast wake from sleep and idle 1 microseconds typical, 8 use selectable frequencies from 31 kilohertz to 8 megahertz, provides a complete range of clock speeds from 31 kilohertz to 32 megahertz when used with phase-locked loop, user tunable to compensate for frequency drift, secondary oscillator using timer 1 at 32 kilohertz, fail-safe clock monitor, allows for safe shutdown if peripheral clock stops. Peripheral highlights: high current sync, source 25 milliamps, 3 programmable external interrupters input change interrupts, up to 2 capture compare PWM CCP modules, one with auto shutdown, 28-pin devices, enhanced capture compare PWM ECCP module, 40 to 44-pin devices only, 1, 2, or 4 PWM outputs, selectable polarity, programmable dead time, auto shutdown, and auto restart. I'll read this later. Peripheral highlights continued. Master Synchronous Serial Port MSSP module supporting 3-wire SPI, all 4 modes, and I2C master and slave modes. Enhanced addressable USART modes, supports RS485, RS232, and LIN26 or J2602, RS232 operation using internal oscillator, block, no external crystal required. Okay, well that's kind of cool. I guess don't need an oscillator, so that's helpful. Auto wake up on star bit, auto baud detect, maybe for, say, like an LCD, or like a serial monitor, maybe for like serial printing. 10-bit up to 13-channel analog to digital AD converter module, auto acquisition capability, conversion available during sleep, dual analog comparators with input multiplexing, programmable 16-level high-low voltage detection module, supports interrupt on high-low voltage detection, special microcontroller features, C compiler optimized architecture, optional extended instruction set designed to optimize re-entrant code, 100,000 erase write cycle enhanced flash program memory typical, 1 million erase write cycle data EEPROM memory typical, flash/data EEPROM retention, 100 years typical, self-programmable under software control, priority levels for interrupts, 8x8 single cycle hardware multiplier, extended watchdog timer, WDT, programmable period from 4 milliseconds to 131 seconds, single supply 5-volt in-circuit serial programming, ICSP via 2 pins, in-circuit debug, ICD via 2 pins, wide operating voltage range, 2 volts to 5.5 volts, programmable brownout reset bore with software enable option. Okay, BOR stands for brownout reset. Okay, it's got the different devices, and I'll highlight the one I have. And it has the lower flash bytes of memory. I guess maybe that's could be a distinguishing feature between the different chips. I guess mine has a little bit less, 64K for the larger chip, which is almost twice as much as the Arduino. In fact, exactly twice as much. Number of single word instructions. I guess that's the number of words you can have almost. SRAM bytes, 3.9. That's like the working memory. EEPROM is 1 byte. I guess the I/O pins after the power pins, of which there is 4 for ground and VCC. BDD is 36. 10-bit analog to digital, 13 pins. I think I read that in the reading that 13 pins are capable of being analog pins. Was that right? PWM 1-to-1. Not sure what that is. SPI Y, master I2C Y, EUSART, comp, timers, 816-bit. Here are the other chips. Here's the one I have, which I guess is the same pinout as the 4620, but maybe the 46 going past these. Okay, so here's a table of contents, which actually might be worth reading. Device overview, did I cover that already? No. This is page 4, and then, so I haven't even gotten to device overview. Oscillator configurations, power managed modes, reset, memory organization, data EEPROM memory, flash memory, 8x8 hardware multiplier. I guess this is good because I might actually get some explanation as to what these things are. Input, oopsie, I forget where I was. Maybe I was here. I/O ports, interrupts. I don't know, did I read this? Reset, memory organization, data EEPROM memory, flash memory program, flash program memory, timer modules, I/O ports, interrupts, capture compare, enhanced capture compare, master synchronous serial port, enhanced universal synchronous receiver transmitter, 10-bit analog to digital converter module, comparator module, comparator voltage reference module, high-low voltage detect, special features of the CPU, instruction set summary, development support, electrical characteristics, DC and AC characteristics, graphs and tables, packaging information, revision history, device differences, conversion considerations, migration from baseline to enhanced devices, migration from mid-range to enhanced devices, migration from high-end to enhanced devices. I think those are all the different chip classes. The microchip website, customer change notification service, customer support, reader response. Looks like customer feedback if there's errata in the data sheets. This document contains device-specific information for the following devices. And here's mine. And actually it's got more chips. Looks like the same one, but I don't know what the LF stands for. This family offers the advantages of all PIC18 microcontrollers, namely high computational performance at an economical price, with the addition of high endurance, enhanced flash program memory. On top of these features, the PIC family introduces design enhancements that make these microcontrollers a logical choice for many high-performance, power-sensitive applications. New core features, nanowatt technology. All of the devices in the PIC18 family incorporate a range of features that can significantly reduce power consumption during operation. Key items include alternate run modes. By clocking the controller from the timer 1 source or the internal oscillator block, power consumption during mode execution can be reduced by as much as 90%. Multiple idle modes. The controller can also run with its CPU core disabled, but the peripherals still active. In these states, power consumption can be reduced even further to as little as 4% of normal operation requirements. On-the-fly mode switching. The power-managed modes are invoked by user code during operation, allowing the user to incorporate power-saving ideas into their application's software design. Low consumption in key modules. The power requirements for both timer 1 and the watchdog timer are minimized. See section 26.0, electrical characteristics for values. Multiple oscillator options and features. All of the devices in the PIC family offer 10 different oscillator options, allowing users a wide range of choices in developing application hardware. These include 4 crystal modes using crystals or ceramic resonators, 2 external clock modes offering the option of using 2 pins, oscillator input, and a divide by 4 clock output, or 1 pin, oscillator input, and the second pin reassigned as general I/O. 2 external RC oscillator modes with the same pin options as the external clock. internal oscillator block, which provides an 8 MHz clock and an INTRC source, approximately 31 kHz, as well as a range of 6 user-selectable clock frequencies between 125 kHz to 4 MHz, for a total of 8 clock frequencies. This option frees the 2 oscillator pins for use as additional general-purpose I/O. A phase lock loop frequency multiplier available to both the high-speed crystal and internal oscillator modes, which allows clock speeds of up to 40 MHz. Used with the internal oscillator, the PLL gives users a complete selection of clock speeds from 31 kHz to 32 MHz, all without using an external crystal or clock circuit. Besides its availability as a clock source, the internal oscillator block provides a stable reference source that gives the family additional features for robust operation. Fail-safe clock monitor. This option constantly monitors the main clock source against a reference signal provided by the internal oscillator. If a clock failure occurs, the controller is switched to the internal oscillator block, allowing for continued low-speed operation or a safe application shutdown. 2-speed startup. This option allows the internal oscillator to serve as the clock source from power on reset or wake up from sleep mode until the primary clock source is available. Other special features. Memory endurance. The enhanced flash cells for both program memory and the data EEPROM are rated to last for many thousands of erase-write cycles, up to 100,000 for program memory and 1 million for EEPROM. Data retention without refresh is conservatively estimated to be greater than 40 years. Self-programmability. These devices can write to their own program memory spaces under internal software control. By using a bootloader routine located in the protected boot block at the top of program memory, it becomes possible to create an application that can update itself in the field. Extended instruction set. The PIC family introduces an optional extension to the PIC18 instruction set, which adds 8 new instructions and an indexed addressing mode. This extension, enabled as a device configuration option, has been specially designed to optimize re-entrant application code originally developed in high-level languages such as C. Enhanced CCP mode. In PWM mode, the module provides 1, 2, or 4 modulated outputs for controlling half-bridge and full-bridge drivers. Other features include auto shutdown for disabling PWM outputs on interrupt or other select conditions, and auto restart to reactivate outputs once the condition has cleared. Enhanced addressable USART. The serial communication module is capable of standard RS-232 operation and provides support for the LIN bus protocol. Other enhancements include automatic baud rate detection and a 16-bit baud rate generator for improved resolution. When the microcontroller is using the internal oscillator block, the EUSART provides stable operation for applications that talk to the outside world without using an external crystal or its accompanying power requirement. 10-bit analog to digital converter. This module incorporates programmable acquisition time, allowing for a channel to be selected and a conversion to be initiated without waiting for a sampling period, and thus reducing code overhead. Extended watchdog timer. This enhanced version incorporates a 16-bit prescaler, allowing an extended timeout range that is stable across operating voltage and temperature. See section 26.0, electrical characteristics for timeout periods. Details on individual family members. Devices in the family are available in 28, 40 to 44 block diagrams for the two groups are shown in Figure 1.1 and Figure 1.2. The devices are differentiated from each other in 5 ways: flash program memory, AD channels, I/O ports, CCP and enhanced CCP, and parallel slave ports. All other features for devices in this family are identical. These are summarized in Table 1.1. The pinouts for all devices are listed in Table 1.2 and 1.3. Like all microchip PIC18 devices, members of the family are available as both standard and low voltage devices. Standard devices with enhanced flash memory designated with an F in the part number, such as PIC18F, accommodate an operating VDD of 4.2 to 5.5. Low voltage parts designated by LF, such as the PIC-LF function, offer the extended range of 2 to 5.5. Well, in that case, I'm thinking the parts I ordered are not the low voltage one. Table 1.1, and this is the chip. Operating frequency, DC, like up to 40 megahertz. Program memory bytes, it was a little bit less, like 48K. Program memory instructions, these are like the number of words you can use. Instruction words. Data memory in bytes. Data EEPROM memory, it's the same across them all, 1 kilobyte. Interrupt sources, 9 interrupts, maybe 9 pins. I/O ports, so there's 4 different ports, A, B, C, and E. Timers, there's 4. Capture compare, PWM, I guess the 40 pin mode has 2. Enhance capture compare, 0. Oh no, sorry, this is the one I have. But they're all relatively the same. Serial communication, MSSP. Enhanced USART. Parallel communication, yes. 10-bit analog to digital mode, yes. 10-bit analog to digital module, 13 input channels. Resets, pour bore reset instruction, stack full, stack over, underflow, PWR, RT, OST, mClear optional, WDT. Programmable low voltage detect, yes. It seems to say that this is the block diagram, for just these two. Hold on. This is interesting. It seems a little bit beyond my understanding at this point, but maybe it's worth studying. So anyway, here's the A, B, C, D port. Okay, so this was the chip I had before, so it has A, B, C, D, and E, so it has all these different ports. And I think I'm getting a little bit tired, but this is neat because table 1.2, this isn't the chip I have, but this table talks about the pinouts and what they all mean. So I think this is the, no, it's still the wrong chip. So this table 1.3 has the pinouts for the chip that I have. So it talks about master clear, or programming voltage input, master clear reset input pin. This pin is an active low reset to the device, programming voltage input, digital input. And all these other pins, like oscillator pins. This would maybe even be worth making a separate video on, or like an additional video to this one, talking about all the different meanings of these different acronyms. 2.0 is oscillator configurations. Okay, well, I'll stop it here for now.